Welcome back to Math 104. If the odds that Rutgers wins its next game against Michigan are 5 to 1 against, then what is the probability that Rutgers will win? We have to be a little bit careful here about how the odds are stated and what's being asked. So the odds are very much against Rutgers winning, so the probability that Rutgers will win should be much less than 1/2. We are given odds, so we should immediately go to the strip diagram and see what it tells us. There are 5 plus 1 different things that can happen, so I've drawn a 6-box strip diagram. One of them is going to contain the letter R for Rutgers winning, and the other 5 will contain R complement for Rutgers not winning. So for every 5 losses, there is 1 win. That's what it means that the odds of winning are 5 to 1 against. So what is the probability that Rutgers will win? Well, it's 1 out of a total of 6. A 1/6 probability of winning. Continuing with the same example, suppose someone offers you the following bet. If Rutgers wins, you receive $10, but if Rutgers loses, you pay $3. Is this a good bet from your point of view? We've already thought about what an ideal data set looks like, so I've got a $3 loss in 5 out of the 6 boxes, in 5 out of the 6 members of the ideal data set, and I've got a $10 gain in the other 1. Overall, for the 6 games in the ideal data set, that is a net loss of $5, so -15 plus +10, that's -5, so a net loss of $5. So we have our conclusion. It follows that this is a bad bet from our point of view. Now notice, it would have made sense if we had been asked, what is the expected gain or loss? And we could have used this information to answer that question. The overall net loss for a 6-game ideal data set is $5. Hence, there is an expected loss of $5 averaged out over those 6 games, 5/6 of a dollar, which is approximately 83.33 cents per game. We weren't explicitly asked for expected value in this game, but we very well could have been, and we have very nearly computed it just in the course of answering this question as posed. It's worth noting that what we just did was an expected value computation using our first method for computing expected values based on ideal data sets. We already had an ideal data set of payoffs in front of us, so it was natural just to average them. But we could just as easily have used our other method and computed -$3 times the probability that we will lose $3 plus +$10 times the probability that we will win $10, and we will get the same result, -5/6 of a dollar. Now we're ready for the next level of sophistication in problems about odds and probabilities. Suppose that the only reasonable contenders for the Big Ten football title this year are Ohio State, Michigan State, and Nebraska. Someday Rutgers might be on that list, but not this year. If you read in the newspaper that the odds are 7 to 1 against Ohio State and 2 to 1 against Michigan State, what are the odds against Nebraska? So think, how can you describe an ideal data set for this experiment? If we look at this just from Ohio State's point of view, then an ideal data set would be drawn as a strip diagram with 8 boxes. I'm going to put an O in one of them for Ohio State winning, and then just leave blank spaces in the others for Ohio State losing. Similarly, Michigan State, if we look just from Michigan State's point of view, with 2 to 1 odds against, now I can draw a strip diagram with 3 boxes, and I will label just one with an M. How can I put all this together into one big diagram? Well, I'll need a number of boxes that is divisible by 8 to accommodate the information about Ohio State, and I'll also need the number of boxes to be divisible by 3 to accommodate the information about Michigan State. Ultimately, when I've formed my big diagram, 1/8 of the boxes will need to have O's in them, and 1/3 of all the boxes will need to have M's in them. We can accomplish this with a table that has 3 rows corresponding to the Michigan State diagram and 8 columns corresponding to the Ohio State diagram. So 1, 2, 3, 4, 5, 6, 7, 8. By analogy to this diagram, I'm going to write an O as the first entry in each row. This guarantees that in the diagram as a whole, one out of every 8 boxes contains an O. I'm going to follow a similar principle regarding the M's and put an M at the top of every column in the hope of ensuring that 1/3 of all the boxes will contain M's, except that I can't put an M in this upper left box here, so I'll put that leftover M right there. 8 boxes are filled in with M out of 24 boxes total, so that's 1/3 of the total, so I'm correctly representing the relative frequency of M among the 24 outcomes in our ideal data set. Now, this represents, within our ideal data set, all the victories by Ohio State or Michigan State. Since there are only 3 contenders for the Big Ten title, it must be that all the rest are Nebraska. And if we count up, it turns out that there are 13 of these boxes that correspond to Nebraska. That means that for every 13 ways that Nebraska can win, there are 11 ways, if you count them up, that Nebraska could lose. So there are 13 to 11 odds in favor of Nebraska. But if we are a little bit careful and go back to the original wording of the problem, we are asked for the odds against Nebraska, and those are just the numbers reversed, 11 to 13 odds against Nebraska. So that's one method, and that works perfectly well. But it's worth understanding that there's another method based on finding the probability of Nebraska winning or the probability of Nebraska losing, and then converting that back to odds. So we can call this strategy number 2, to work with probabilities as much as possible. We are given that the probability that Ohio State wins equals 1/8. We are given that the probability that Michigan State wins equals 1/3. Therefore, the probability that Ohio State or Michigan State wins, which is the same thing as the probability that Nebraska loses, these are equivalent. Someone other than Nebraska winning is equivalent to Nebraska losing. And we're assuming here that these are the only 3 teams that could possibly win. The probability that Ohio State wins or Michigan State wins equals the probability of a union, but that's a union of mutually exclusive events. It cannot be that both Ohio State and Michigan State win, so the probability that Ohio State or Michigan State wins, the probability of the union, is just the sum of these individual probabilities. That equals 3/24 plus 8/24, which is 11/24. That's the probability of Nebraska losing, and therefore the probability that Nebraska wins equals 1 minus 11/24, which is 13/24. If we put all this together and draw our conclusion about odds, it is that the odds against Nebraska, which is what we're asked for, are 11 to 13. Because there are 11 ways that Nebraska loses for each 13 ways that Nebraska wins. So by this method, we get the same result as by the first method. And that is all that we are going to say about odds.